Hey guys, welcome to devops school. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps School certification level courses which will help you to emerge skills for a wide range of entry level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
Okay, so we discussed about what is Docker and what is container. Now, next question is, what are the components of Docker? Components of Docker. Next, before that, what is the architecture? What is the architecture? Architecture of Docker. Or in a simple way, I'm going to work with how Docker works. Or how Docker works, right? That's the thing. How Docker works, I have given you great explanation. So, but a little bit more is pending. So, what is the architecture of Docker or how Docker works? What are the components of Docker? Now, Docker life cycle, okay, and container life cycle. So these are the things which we have. So here, let's get started, guys. So here I'm going to talk about here Docker architecture. So here you have a human being, right? Human being interact with the Docker client. Okay, Docker client interact with the Docker daemon, Docker daemon, DEAOMN, Docker daemon, and here this is through REST API. Okay, REST API. So human interact with the Docker client interact with the Docker daemon interact with Docker daemon interact with a container D interact with the system and system D and the source. So this is the one. So now this is called Docker engine. This is called Docker engine. This is called runtime, container runtime. Okay, this is called runtime. Now this is kernel. Okay, so guys, this is the how Docker works. So I communicate with Docker client send the API, send to the rest the request to the Docker daemon, Docker client together is called Docker engine, and here Docker daemon connect to the container D. Container D is an open source container runtime tool which create environment, container environment. Container D communicate with the system D, which is the kernel. So guys, this is the overall workflows of how Docker works. Okay, now client daemon container D, I'll show you that during the demo. All these utilities, this is how it works. What are the component of Docker? So guys, component of Docker is first thing Docker engine. Yeah, Docker engine, and Docker engine, which I said already, you have Docker engine. So here Docker client, Docker daemon connect together, Docker engine. Now second thing is Docker what is that Docker engine, and second one is Docker image. Now third component is Docker registry, and fourth component is Docker container. Docker container. So here container. So here you have a Docker engine. What is a Docker engine? So it's a Docker client and a Docker daemon together. It's called Docker engine daemon. Okay. Now Docker image. What is a Docker image? So Docker image, I think I said very clearly to all of you. Docker image is this one. This one. In a simple way, i.e. in a simple way, your application. That's all. Okay. So Docker image. What is a Docker registry? A place where from where you can download Docker image. Download Docker image. So a place from where you can download Docker image. So that means a registry has a repository, multiple repositories, and repository has Docker image. Okay. So Docker image is a root file system, user file system plus application file system. Okay. Now Docker container. I said very clearly Docker container. A moment you run image, one copy of flatten image. Okay. Get mnt to here the technical word. One mnt is like mnt mount to what? User namespace with net and pmap. Same definition. Okay. Pmap. Okay. So this is the container. You know very well. So guys, did you understand that what is how Docker works and what are the components of Docker? Any questions here? Guys, any questions?
Can you scroll a bit up?
Yeah, sure. Guys, any questions?
Rajesh, let's say I have my application deployed using Docker. Okay. So say when my application receives a request, excluding the application architecture, can you help us going through the set of steps that it goes through?
Yeah. Simplify your question, please.
Say if usually when I let's say my application is deployed in a domain. When I try to hit it, it goes via browser and it hits. That's how the normal request goes, right? Now when I say my application has been deployed in the Docker, what is the first layer that it gets hit, and how does it reach to the application resource that has been deployed in Docker?
Okay, so right now we remember we have a network actually, IP address. Okay, we have a one network, each container get one network, right? So here through network, that's all. IP address, port.
No, it's like we have different set of components when Docker is concerned, right? So how does it pitch in over there? I'm just trying to understand in the Docker how it goes, the flow in Docker.
Okay.
Did I make myself clear? Is my question understand?
No, actually, when I say workflow in Docker, so life cycle workflow in the Docker, I can talk about workflow in Docker. So here workflow in Docker, so that I'll talk about it. But my topic is I'll talk about that's a pending. So that is pending. But here my topic is components of Docker. That means what are the building blocks we have: Docker engine, Docker image, Docker registry, Docker container.
Okay, here when you said that REST, right? Is it the RESTful request that you're talking about, or?
Yeah, restful. Rest means restful. Yeah, the same thing.
Okay, this is what I was interested to have a thought on. So here, human in the sense, are we talking about the user of application or user of Docker?
You, not user of Docker. You will interact with the client. Client will send through the request to the REST API to the daemon. Daemon will talk to the container D. Container will talk to the system D, which is a kernel. Kernel
Okay.
will give you all the resources which I discussed above.
Okay, this flow looks good. So now, where does my application reside here?
So here I
And
said no.
the place where I would
So
think.
so see here, Docker
Hmm.
container.
Hmm.
So the moment you run image, I say a moment you run image. Which image? This one. From where you will get it? Registry. So you
Okay.
run image with the help of engine. Engine is what? Docker platform. Docker is a platform. So you run
Okay.
image. From here, you get a container by this one. How? This one. Okay. So the moment you run image, you get a container. This is what I explain you again. Same thing, repetitive.
Okay.
Okay. I'll prove these points while demo. I'm not discussing. I'm not showing you. I'll give you the demo. Let me complete my stuff. Then. Okay. Any other questions, guys? Okay. So now
Satish,
the
one
So
question
my
is,
thing, just
application will run on the image, right?
see here, image. What is image? Image is your application file system, user file system, root file system. Together bundled is equal to one package. One package. That's
Okay.
called image. That's called image. Actually, it's not a package. Let me tell you, but I'm just telling you to make it things easier. When I talk about the tomorrow images, you will love it. This topic is very wonderful. Okay. What someone was asking one more question, I guess.
yeah, I just wanted to know before start of Docker, is there any pre-analysis that we should do in terms of designing aspects?
So you most of the time you spend here, Docker image. This is your heart of this
Okay.
thing. Remember, this is installable.
Okay.
Just you install the Docker engine. This is somewhere lying in the place. So most important thing, 90% of the task will be done here. This is your application.
Okay. Got it. Fine, you go on. Yeah.
So guys, Docker workflow. Before Docker workflow, do we have other tools? Other tools, when I say other tools, means competition with Docker. So many actually, so many. So here, devops.school.com blog, and I was talking about runtime environment, right? Container, runtime, container, runtime. Enter. By the way, this list which I'm showing you is little outdated because I worked in 2019 on this blog. But yes, I have not updated, but I think there'll not be much of the changes here. So you will get some of the tools here. So all these tools of this list you have here. For example, Docker, Arcanet, CRI container, CNI container D, Rocketlet, Cryo, Fracty. So the open source initiative also has been done. So it's like this. So these are the containers. But why Docker is very popular? Because Docker is popular because everyone uses the Docker since many years actually. So everyone is familiar with Docker, love Docker, like Docker, stable for the production uses. So everyone run the Docker. But nowadays there's one more tool which is becoming very popular in the Kubernetes world. Basically, that's called Podman. So Podman is one of the tool which is not there in the here. So you can check this out also, Podman. Okay, so you can check this. Okay, so many tools are there. Try Podman. Probably it will be new ways to run containers and stuff like that. Okay, so now workflow in the Docker. So here what happens, understand this. First I'll draw image. Probably will be more easier for you guys to understand. So this is the host. This is your laptop, desktop, VMs, whatever it is, I don't care. So here this is the one. Here Docker is installed. Okay, Docker is installed. Now what happens, you are the one, and here when it's a Docker, this is a client installed. Okay, client, this is a daemon. Okay, so now you say Docker run what? I said no very clearly. Look at this. A movement, spelling mistakes here. Movement you run image. So here I say Docker run what? Image. So image name is, let's say, XYZ, or let's put it up Jenkins. Okay. So now what happens? This you need to understand. What happens when you do this? The moment you run image, Jenkins is an image name. Okay. Image name. Okay. So what happens actually? You get a container. But how? So that is what we call it Docker workflow of Docker. Okay. So what happens? So I run commands, I send to the client. Okay. Client send to the daemon. Daemon will check in the repo, local repo, LR. LR means local repo. Do I have this image? He will ask, do I have this image? Which image? Jenkins image. No, first time you run. So that Docker will go and travel to registry. Okay. Now what is the registry? A registry is a place where you have a repository. Repository has an image. So here there's a two kind of registry: public registry, private registry. So public registry means hub.docker.com. Okay, hub.docker.com. This is a public registry. I'm just giving you one example of it. Okay, there's many public registry nowadays. Google registry is also there. ECR is also there. So many registries are there. But private registry, like for enterprises, like Artifactory. Okay, Artifactory is your private registry. One example. Again, there are so many private registries are there. So please understand that. So here he'll go public registry, which is the one default one, hub.docker.com, and we'll download the image, keep it in the local. And the moment you have image, from the image you get container. This is a container. So container will be managed, created by container D, CD, C, D. I'm saying container D means CD. Okay. And so container D will talk to your kernel. This is the kernel. So this is how, I mean, at a high level, don't want to confuse the too many things again and again. So, but this is how it happens. So guys, did you understand that? You send the client, you have Docker D, image is there, create a container. If image is not there, download from the registry. Did you understand that? Guys?
Yes.
Okay, good. So here I must write it, you'll forget it list. Here human client Docker D check in the local repo, not found, public repo, to local repo, container is ready by container D. That's all. Understood this?
Yeah.
Okay, guys. And now next question is life cycle of container. Forget about this now world of Docker. Container. What is a container? Again, forget about the container one time. Tell me life cycle of VMs. What is the life cycle of VM? Anyone would tell me life cycle of VM?
Sorry, Rajesh. So
Yes.
I'm sorry to just going back to your previous statement. So does that mean that all the host machines should maintain the images?
Host machine has to have a local repo which has the images. Here, local repo
Okay.
will have it.
So
This
basically,
is the center. This is the Docker.
Okay.
Remember images.
So let's say if I have
images you don't have in the local repo. See, images if you don't have in local repo, how can you create a container? See here, one copy of flatten image, same image, get mount to user with NNT and that map. That's called container. So one copy.
Okay.
So that means 10 container, 10 copy of image, flatten image.
Okay. So, but that is has any recycle, because let's say now image is updated, how that local repository knows that this latest version is available in the public repository in that case, as per your logic? Because it doesn't check if it is there, it launches, right? If I have the latest version?
So how much time it takes to create a user or container?
Less than a minute.
Less than a second.
Yeah.
So don't think even to upgrade. Think to replace. That means new version of image has come. So pull this image in the local repository and create a new container out of it, because it takes less time than upgrading the stuff. Are you getting points?
Yeah, I understood. My question is, do we need to do manually, or the repository get updated automatically?
No, nothing will be done automatically. Everything has to be done manually. But that is where the Kubernetes will come. Will do automatically many things. I was discussing somewhere. I forgot actually.
It's okay. I got it. Your point. Understood.
Yeah. Orchestration required for that.
Got it. Yeah.
Yeah. So guys, I was talking about the life cycle of VMs. So now the question is the life cycle of VMs. So VMs, right? You guys are using VMs technology from last 15 years, I believe. If you are having, you've been working along with, when I joined my organization, first organization. So you tell me, what is the life cycle of VM? I remember I was using, I started using VM from my first year of my joining itself. And I was very confused about the VM technology. I remember at that time. Tell me. Guys, are you there? Hello?
Yeah, Rajesh.
Yeah. So life cycle of VMs. You tell me.
Anyone going to answer, guys? Anyone?
Yeah.
I'm just asking. I don't want to answer all the questions. Just asking, is anybody going to answer the question? What you asked?
So Agustin, I think you have already. If I have a good memory, I think you have. Yeah. Okay. Yeah. I got confused actually. Yeah.
Yeah. That is why I'm not saying a lot of things. Just want to keep quiet.
No, that's good actually, because I remember you were in the last session also.
Yeah.
Okay, other guys. Okay, I think we need to be a little bit more interactive. This is a competition between the last batch and this batch, and I think last batch were more active in terms of questions. Everyone were participating, and we spent a lot of time on the question, answering a question itself. Trust me on that. So let's be interactive. Huh?
I remember they were experienced people too.
Yeah. So you're saying you are not experienced?
Not as much they are.
Okay. No problem. So here,
I would like to say something. Basically, what we do is we create a service and then we start it. Is it like what we do in VM? Start it and then we can stop it, and it will be destroyed.
Correct.
Not deeply, but what I know is we create, we start, we stop, we destroy it. But if in between it is down, then system will fail.
Right. Yeah. Get it. Yeah. So here, what we do in a VMs we are using from last 15 years. So we create a VM. Okay. I don't need to teach you. You know that more than me probably. But you need to create a VM. Then you need to start a VM. Then you need to stop the VM. If you stop, then you can restart. I mean, you can start also, but restart. Let's restart. Okay. Restart means let's do one thing. You can start this and then restart. Okay. So all these things you can do that. When it's a restart, it's running, you can pause it, and then you can unpause it. After that, what you can do, unpause it. If it is running, then you can kill it. So kill. Okay. So kill, and then finally you can remove it. Now here I am not having. I need some help from you also. This is assignment. Okay. I need to know difference between pause versus unpause. Not now, don't get scared. I will ask you later, okay? And stop versus kill. Okay, what is the difference? You need to teach me, okay? But not now, end of my session. Okay, so life cycle. So guys, this is the life cycle of VM. So something similar we have in a containers also. Okay, so now I think this is the life cycle of container. You create a container, start the container, stop the container, start the container, stop the container, start the container, restart the container, pause the container, and pause the container, kill that and remove it. End of the story. That means when I say container, it's your applications. Remember, I said very many times, it's your applications. Okay, it's your applications. Okay, so now no more discussion, guys. How to install Docker? Okay, so now I'm going to give do the demo. So let's get started. So let me start from the scratch, because I have to teach you each and every steps. It's advanced training, so I cannot skip even one steps. So here I'll stop this. Why to waste money? And let's create one instance. So here I'm creating instance. Okay, and here, because we all are using CentOS, so we will use the CentOS. You guys are using CentOS or Ubuntu?
We are using CentOS, right?
Okay, CentOS. So I'm using CentOS 7, which is in production right now. This image is a paid one, but it's okay. I'll go for 1 CPU, 2 GB RAM. That's okay for running this. One machine here, 20. That's more than needed. Here, Docker Rajesh. Security group. I'm now opening up every firewall. Remember, system firewall. Okay, launch. Here, keys I'll give it to you. Don't worry about that. Rajesh have an MBA, Mumbai. And here, view instances. Okay, so I got these machines here, and this is my IP address. This is my IP address. I'll give you the IP address for you also. Just give me some time. Meanwhile, where is the installation instructions which you have? So just to get a habit of it, I think it will benefit you.
Rajesh, your audio and the visuals are lagging.
Oh, is it? Is it okay?
Rajesh, all we
Let me
the loading on your screen, we can't see anything apart from that.
Okay, so internet is quite well, I guess. I don't know what is the reason for it. Internet
Actually,
stable.
we can see it. I think you should check it your end on it.
Yeah. Let me just a second. Hold on. Give me 2 seconds. What about now? Guys, what about now?
We can hear you, Rajesh.
We
I
can
think
hear
the
you.
issue is not at your end.
Okay, great. My end?
No, I think it's
No,
on
no.
their end. Yeah, because we are
Yeah.
able to see everything.
So
Yeah,
we are able to
you
see
can continue.
consistently.
Yeah.
Okay, guys. So now installing the Docker. Okay, I have instruction which I am following in front of you. URL is also with you. So now I'm going to log in. So here I'm going to use PuTTY. I'm sure about that you have experience with PuTTY, but I have a keys. I don't have a password. I have a keys. I'll give you the keys. So you see that. Look at my screen. How I'm using the key. Auth. Locate the key, which I'll give it to you, and done. So this is the machines. Let me improve the settings. click OK, apply. So guys, this is a EC2 user, EC2-user is a username. Okay, sorry, I think it's a different machine, so it's a CentOS user. Again, I'm connecting it. Username is CentOS, not EC2, because this is a different AMIs. Okay, so 16, click OK, click apply. So here what we have, guys, Docker needs, I'll make one statement here. Docker needs root, understand that, root, or user need to be a part of group called Docker. That's all. So this is the requirement for running the Docker commands. Okay, for Docker commands, understand that, for Docker commands. Okay, but right now I have a habit to become a root. You can also become a root, no problem. Either you try sudo also, no problem. So here I will install the Docker. This is the remove instruction, don't follow. Here, from here, become a root, and from here these are the installation in yum, CentOS and RHEL. Ubuntu again is such simple. In the same, if you go a little bit back, you'll find Ubuntu instruction. Official websites are also very good, and nowadays official document is very good and up to date also. But I use my notes because that way it saves my time also and your time also. So okay, I'm not going to explain each and every commands. I think you should be comfortable with it. So that way, because others will lose the time explaining each and every things itself, and then will not learn Docker, those tools. So I assume you are comfortable with working with Linux, and if you are not, no problem. Again, I have a commands for each and every scenarios. You have to see me do it, get the confidence, ask me a questions if you have some confusion. So I'll help you with that and get going. Okay.
Please enroll for our channel membership 399 plan to get access of all the parts.
Okay, see here, I install this Docker, enable it for the tomorrow, and then start the Docker. Okay, now can I validate the Docker? Can I validate the Docker? Docker info, and here it is. Now guys, whether you understand or not, again I repeat, whether you understand or not, each and every rows of this info command output, please read it. Whether you understand or not, hardly I care, but read it. Okay, so after this, which version of Docker? It's 1.19 19.3. I think it's the same one which I was saying. Okay, which Docker? This is the client, ps-ef docker grep docker. This is a Docker D, I said, right? Docker D. Look at this here, correlate the discussion. Where is the Docker D? See here, I connected client send the command to the Docker D to container D to system D, Docker D and container D, which is listening. Here it is in SOC. Okay, so this is the one. Look at this. Docker D is running with a 9010, and 90 is the parent ID of 1 actually. Let's understand this. So that is how it works. Now this is how it works. So now we have installed all this thing, and here is the command which I followed. So you should not be in a confusion state like what I did to install this. These are the commands. Okay guys, any questions so far? Any question so far?
No.
Okay, so now guys, so we need to now run the life cycle of VMs. Okay, life cycle of VMs. So let's get started. So we need to do this one. So here we need an image. So where's the image actually? So here, remember that I said the moment you create a container, so you need to run image. So the moment you run image, the Docker D will check, do we have an image in the where local repository? How do I query local repository? So Docker images is a command to query the local repository. Do I have any repository? See here, I said image is inside a repository. Don't skip any topics here. I said very clearly Docker image. Okay, Docker image. See here. Registry has a repository, repository has a Docker image. So please mindful about it. Okay. So here I have a no image. So can I go to the dockerhub.com, hub.docker.com, hub.docker.com. Okay. So guys, we have 20 people. Okay. 20 people. Tell me what applications you want to run in the container. That's a question, simple questions. And we have 20 people, 20 applications. So I will start, you will tell me the name. Okay. So Alugiri, tell me your application quickly.
So what application in the sense? I mean, what do you want me to?
Any application. Any application.
Like a Tomcat, MySQL, any application software.
Okay. Fine, I'll just go with Tomcat.
See, it's cheating, right? It's a cheating.
No, it's like I didn't get the question. When you say what application, I'm not sure what you actually meant in that application code.
Application means application, simple. I should not teach you application. What is application? Application means MS Office, Tomcat, Fedora, Debian. These all are application. Whatever you run in the system is application.
Context over here, that's it.
Okay, no problem. So, but you have to tell something, but right now I'm considering Tomcat for you. Okay. Amit, any applications? And one more thing, tell application which you are currently working on. Don't tell any other application.
Nginx.
Currently working on. Nginx?
Nginx. Yeah.
Okay. Aradhana?
Yeah, database, MySQL.
Tell me MySQL. Wonderful. Gopinath?
How should I tell?
Anything which you are working, day-to-day activity. Don't go far.
Actually, we are using all these things, Tomcat and MySQL. One second. I couldn't.
Else? And you know
Sonar?
one thing, this is not Sonar. Okay, yeah, wonderful. Tell me, Jitendra. Jitendra, are you there? No. Koel, Mahana, Maheta.
Jenkins.
Jenkins, wonderful. Okay. Mahanohar.
Sorry, I was muted. Git.
Git. Okay, wonderful. Sorry, I missed the flow. I guess. Manohar, I did. Pooja. Pooja.
PostgreSQL. Postgres.
Which one? Postgres. Right. Right. Yeah. Pooja. Done. Prerna. Robin.
No.
So we use Spring Boot for backend. So it inbuilt uses Tomcat only.
Yeah, Spring Boot is also okay. No, it's okay. Fine. Spring Boot is application. Anything is application. So that's one. Saurabh.
Redis.
Yes, wonderful. Saurabh. Seema.
Solar.
Okay. Are you Are you using Solar? Elasticsearch is a good one, right? Okay.
Yeah, we are
Sort
using
of. Yeah. Seema done, right? Shivam.
FTP.
FTP. Okay. And Shriram. Shriram, I think there's a bad problem from your side. I don't know what is the reason for it. Your voice is robotic. So yeah, I'll move on.
You can send a chat. You can
Sriram.
send it in chat if you're not able to talk clearly.
Yeah. Shubham.
Gradle.
Gradle. Wonderful. Gradle. Shushma.
Zabbix.
Javix. Wonderful. Vanishka.
Coco or Elasticsearch, maybe.
Elasticsearch. Okay, so guys, this is your assignment. Okay, whatever is your applications, you know your applications more than me. So this is your applications. This is your assignment. You need to run these containers. How can you run? I don't know. You have to find out that ways. I'll teach you one of the applications with Docker. Okay, container. So now guys, what application you want to run inside a container? So look at this here. I am taking one of the application which is very popular, Jenkins. Why I'm taking Jenkins? Because it helped me to create my scenarios for Docker, not for application. I don't want to teach you applications. I am not teaching you Jenkins right now. Understand that. But what is a Jenkins? Jenkins is a web-based tool. Web-based tool. Okay, it's a Java-based tool. Java-based tool. It has an agent also, right? So now Jenkins runs required Java required some operating system, root file system. Understand that, root file system. And then it required root file system required a boot file system, kernel, basically kernel. Understand that. So this is the depictions of this. Jenkins required Java required root file system. Root file system is like OPT, etc, this, that, and all. And then boot file system. Root file system required a boot file system. I explain you in a very detailed manner. So guys, now Jenkins run on web is running the 8080 port, and agent is running with the 50,000 port. So it's a web-based application. You can understand that. So this is the all about this Jenkins. Okay. Now I am going to work with it. So here, guys, create, start, stop, restart, purge, unpurge, all this thing. I'm going to do that. So look at it. Docker create. So do I have images? Docker images is not there. Do we have any container running? No container. PS means running container. PS-A means running an exited container. Understand that. PS means running container. PS-A means running plus exited containers, means all containers. Okay. So here, how do I get the images? So I will go and hub.docker.com. I will try to find it out. Simple. So here, if I go and try to find out Jenkins, see here, I get so many images, and that filtered by many things. Actually, you can study these filters later on. Certified, verified, official image, these are the category. So we have a filter. Right now I see here, look at my screen here, look at here you have official image. How many downloads, how many stars, look at this. Decide how many results you have come. This, see, so many results has come, but this is official image. You have more images. Look at the download, look at the stars, and you use that images as per your wish. I want to use this image, Jenkins image. So how do we get it? Do you want to download this manually? So docker pull. Remember, just pull. Docker pull Jenkins. Automatically it will download from the hub.docker.com, because hub.docker.com is a default registry. It's downloading an image. Okay, so look at this. Okay, so here the Docker image, see that this is the image repository, Jenkins with a tag latest image ID 24 months ago. It got created, size is 700 almost. So this is image. By the way, let me tell you here, guys, if you create it will do the flow which I already explained it. It will try to find out the image in the local registry. If not there, it will download, which I said very clearly, please lock it. Okay, please lock it. So let's get started. So can I create images?
I'm sorry to interrupt, but I have a question that in case we do not have an image in local, and we also do not want to download it from Docker Hub, which is like the default, but maybe from ECS or any Fargate, anything. So how do we configure that?
Yeah, so there's a two ways to do that. One is like you set the default registry, that's the one way. And second way, instead of typing Jenkins, you give that Docker full HTTP,
The address. Okay.
that whatever the location and full locations, IP address. Got it? So
Yeah.
both the ways, okay. Okay, so guys, I will go through this creating the container, okay, which is here. Okay, so which is here. So guys, look at my screen, please. Clear the screen. Docker create Jenkins, because you create a container from image. Docker ps. Docker ps. You see here, there is no container running. Created container ID from image. Container is running with this command internally. Created status name. Okay, so container got created. Start. Started the container. See, running. Now you see status up for 4 seconds. Stop. Docker stop. Not running. What happened? Exited. Why? How come? So earlier, when you create a container the first time, it's created. But how come when you stop the container, it exited? So any container which has run at least once, understand that, very simple logic. Any container which has run at least of one time, that will be exited. The container which is never ever run will be in a created state. So it's exited means it has run. And start again. Docker start. What? Container ID. And now see that it's running again. Here restart. Can you see that here? Right now it's of 8 seconds. Can I see restart? See, I restarted the container 1 second. See that? So I restarted. Watch. See here. See guys, paused. PAWSED. Paused. Can I unpause it? Unpause it. And you see here, it's again running 32 seconds. Now unkill. Kill. Container ID. And you see when you kill, exited. Okay. Can I remove that? RM. So RM. And guys, so fast. See, clean this whole thing. So in a short, I'll tell you. I created a Jenkins container, started the Jenkins container, stopped the Jenkins container, started the Jenkins container, restarted the Jenkins container, paused the Jenkins container, unpaused the Jenkins container, kill the Jenkins container, remove the Jenkins container. This is the container life cycle, which you flow all the time. Now, you will ask me what is the difference?
Yes.
Yeah.
Okay.
Okay. I have one question. Okay. Can you give me a use case wherein we will use unpause, pause and unpause?
See, you are again, that is what I wanted to know from you. What is a pause? What is unpause? So if I answer your question, my assignment will be disrupted. So this is your work to find and teach me. Okay.
Fine.
Yeah, because I knew you will ask me question, but I also knew what question I need to ask. Okay, so you need to tell me what is the difference between stop and kill, pause and unpause. And assignment number 2, there's a 1, 2, you need to run your applications. After this is a lab, this is an assignment. You have to run your application, see if you can use it in a container. Okay, so all these images, by the way, this you get it on this called hub.docker.com, free of cost. Okay, except this one I don't know, I have to check. So just check this FTP, I'm not sure about it, but FTP again is a protocol. You have to tell what kind of FTP. There's so many FTPs like a FileZilla and so many things. Okay, so okay, so guys, this is the workflow life cycle of container. So here is the command which I run. Okay guys, more questions?
So Rajesh, for the assignment, what kind of expectations do you have from us? I mean, pause versus unpause. Do you want the theory behind it, or do you want us to explore, as in for our containers, what was the difference when we used pause and unpause? Likewise.
First you try, okay, because trying is like a give you another experience altogether. Because you might have experienced by now, reading a text inside a document is not exactly we build understanding with. So try it out, read, try it out, you will find a different definition. If you read the documents, you will find a different definition. Okay guys, now let's prove it. Okay, let's prove it. Okay, so this is the smallest proof I am doing, though you can do that very long way also. Whole day it will take to prove it if I start playing with the namespace, but no time for that. So let's prove it. First thing, what is a container? So container is a user space. So let's find it out. So right
for
now,
our lab will we get the access to AWS EC2 machine? Like what?
Yes, I'll give it to you. Okay. Just give me 10 minutes more. 10 minutes more. Yeah, sure. After that, everything is your time. So I know that I have taken all of your day, but just give me 10 more minutes. Almost ready. Yeah. Okay. So here, container. Just prove it. What is a container? So this discussion we did it, but we did not prove it. Let's understand that. So here, if you see here, what you are. Let's find out what you are. I am what you are. I am one of these. So actually I did 2 times sudo, so I got 2 times sudo exit. Okay, see, root, exit I did, again see a root. So here no problem. So what you are this
process.
You are process. Yes, you are correct, 100% correct. User is a process coming from where? Let's trace it. So here 8660 ps-eaf. So 8660 coming from 8658, which is here. Now let's track it. This one 8658 come from 8636, which is sudo -s. 8636. 836 is coming from 8635, which is a bash. You are coming from somewhere. 35. 635 coming from A632, which is a CentOS. Remember, I created a terminal. A632. 8632 coming from 1241, which is the privileges you are getting here. See, CentOS. Before root I was CentOS. Remember, CentOS. So here 8632 to 1241. 1241 come from, see, this is the 12441. You are the CentOS. Come from CentOS, come from where? PID1. And PID1 1241, which is this one SSD, and SSD privileges you got through. Remember security, remember kernel security, privileges, capability. Yeah, same thing, CentOS. And now this come from what? 1. And what is 1? Look at this here. What is 1? And 1 is system D. I said system D many times. I might have mentioned it. System D. System D is your kernel. Okay, see here. System D is your kernel, and kernel come from where? Nothing. 0. That's your RAM. Okay, so as long as this is running, your operating system is running. So did you understand that this is called one PMAP? So what you are ultimately, guys, what you are what? Process. Yes, you are process. Everything is a process, but we are isolated. Users process. Understand that we have some capability. That means we have a isolation capability. That means no one can touch me if only decided by kernel. Who can touch me means who can come inside me. Okay, so that's understand that. So now Docker. Now let me tell you one magical command. Okay, let's not confuse you with too many things because I'm killing all of your time. So Docker create Jenkins, and here do we have a process right now? See here, it's a created a container. I said created a container. Do we have any container process? Let me check this. See, there's no container process. It's a Docker D which was running all the time. So can I start this? And can I see now? See, you are what? Your process. I said container is managed by Docker. Docker D ask container D to create a container, and container D is running right now. You see that in front of you. Container D is running your container runtime environment. This is your image. So guys, did you understand this? Guys?
Yes.
So you are what? You are process, mere process. Can I stop this container? So can I stop this container? And stop this container, and you are not a process anymore. See that? So you are just a process. So here, yes, you are a process. User process. Okay, user process. Here, isolated user process. So can I do one thing one more time? I'll teach you. PSFNA, sys execute. Just a second, sir. Docker start this container. You want to experience this? See where I am. I'm logged in as a root right now. Docker exec. Don't read the command right now. I'm not asking you to read the command right now, but I'm going inside a container. I said I am going inside a container. I am inside a container. Don't read the command. I'll teach you later, but understand that. See here, I'm inside a container and I'm feeling, what is this? Have you seen this one? Have you seen this one? ls, I'm inside a container. Have you seen this one?
Yes.
Ever?
Yes.
Anywhere?
Root.
Yeah.
What is this?
This
Root
is the entire file system.
Set of packages.
Right. It's a root file system, right?
Yeah.
It's a root file system. What is user file system? This is my user file system. I am on the user file system. This is my desktop. You see, CD when you do, you will get into the user file system. This is my user file system. Some files are there. Now, what is application file system? So you have so many applications. Check it out. Okay, so many applications installed many places. Okay, so many applications. OPT, there is no applications. Var bin, let me check. Some applications will be there. LS and all these are the applications. Where is this LS? See, bin LS. There's so many applications in the bin directory. So these are the applications. These are the applications. These are the applications. Now, what kind of root file system? APT, so Debian file system, Debian root file system. There's so many file system, guys. Debian, Fedora, Ubuntu, CentOS, RHEL, SUSE, HP, Amazon, this, that, so many flavor. More than 69 flavors in Linux itself. I think you have it. Look at this flavors list in the Google. India has a Kali, by the way. You might have heard about it, right? So this, what you are, is just user isolation. I got to see that. So this is the one. Now I said each container also get one network. Now how do we know that? Which mean, so here we have a container. Right now I'm out of this container. Okay, so Docker inspect container ID, and here you have a network. See here, curl http dap 8080. Jenkins container runs on the 8080, right? See here, this is the login page of Jenkins. So each container get IP address. Each container I get IP address. Let me create one more container here. Create Jenkins from same image. I got the two containers right now. See here, one is created, one is running. Get a second container. Docker start within it takes seconds, right? It just takes seconds. See here, Docker ps, and see this is the last container which I created. Docker inspect, get the container ID, and it's the last one 2 is 13 IP address. So each container get IP address also. Okay, so separate IP address. Each container has their own process map. Process map means 0. So can I show you? There's a 2 container running right now. Docker execute in what? This. What do you want to execute? In what? This. What do you want to execute? ps-e. I'm inside running the container. See here, start with 0, 1. Your host machine also start with a 0. I said very clearly, each machine, each operating system has a 1 pmap. So do each container also has 1 pmap. So this is the 1 pmap, 0, 1, 6, 1, 72, 0. These are the pmap starting with 0. Starting with 0. So this is the pmap. So I proved this point also, but what is the last one? I said pmap network MNT. MNT means each container get the same amount. How come? See that. Each container, Docker ps, Docker execute what? This. And what do you want? df-kh. Docker execute what? This container, df-kh. See that. Same amount you got it. Coming from the same image. So each container they got their own mount, but behavior will be different. If you store something in this one container, you see here, one container ls-la, you store something here, you will not be seeing the other containers. So this is the user isolations with a root file system, not user file system. So guys, this is also I have proven, and I think I'm done. My energy is also almost gone. So Docker ps-ef, and these are the commands I run to prove this one. So guys, did you understand what is container, what is Docker, how to work with it, and all this stuff?
Yes. Yeah.
Okay, so now I think we have 1 hour 15 minutes. So sorry I have taken lots of your time, but I wanted to complete this stuff in one go, so to avoid confusion. So I will go back to the now lab time.
Rajesh, I have one doubt.
Yeah.
Hello? Yeah, we are pulling the image from Docker Hub, right? So where we are defining that path key from this registry only we have to pull the image.
So that's a default set actually. That's a default set. Now the question is that is encoded. That's inbuilt in the Docker itself. So hub.docker.com is inbuilt.
Okay,
Now
so
where it's inbuilt? So Docker info, if you do, that's the reason I ask you to read it, no matter whether you understand or not. This is the path in Docker
okay.
info. You can change this path if you want.
Okay.
More questions, guys?
Yeah, I have another question. Like just now we saw that in each container we had different C groups, right? And C groups, they define that what are resources,
No,
how
no,
do
no,
we consume?
no. C groups basically is at the host level. Understand that. C
Right,
group
but
is
how
at
did
the
the
yeah.
actually,
Tell me.
that's what my question is. Right now, we ran that container. We were inspecting that container, no? So I saw that C group was there in both of the containers individually also. So,
This is
so
the
my
same C
question was
group
like,
which
so is this both the containers will have the same C group? That's what my question is.
same. Yeah. Because C groups is the what you are. What is a container? It's a process. And who manages the process? C group. Who manages the assign the process to the container. So it assign the process to the container by the host machine in the kernel. C groups. Okay.
Right.
See, these two containers is a process. So all this process from inside it behave like different, from outside is just a mere process. And all the process of the host machine which is running on the Docker is managed by C groups from the kernel. Did you understand that?
Yes, not completely, but yes, sort of.
Yeah, C groups is managing their, see here. So here, when you create a container, think about it. Forget about the containers. You are a user, okay? And this is a user, okay? Normal user. And you run Apache and Tomcat, two applications. So here, user, this process ID, I'll change the color. So this process ID is a child of this, okay? So this is a child of this, okay? So this, I'll put it in a different way. See here, this is a child, this is a child of what? This. So here, this have a different PID, but this will be, parent will be this. Now this will be parent of PID1. Now all PID will get a CPU from C groups. Here this one will get, this one will get, this one will get, this one will get, all.
Yeah, so basically the C group is at the host level. I understood that thing.
All
So
yeah.
yeah, is it evenly divided like that? How much RAM will be given to one container, or does it depend on how much is the requirement for the current running container? I mean,
that is a good question. So here, I think you know that answer. Let me recall this stuff. System will give you, see here, I'm having 1, 2, 3, 4, 5, 6, 7, 800 process running. System will keep asking CPU and RAM. I'll keep giving it. Okay, that's called batch processing. Okay, so system will keep asking the RAM and I'll keep giving it. I will know if some process will ask too much CPU, too much RAM, and then I will ask other, wait, I'm busy giving this CPU and RAM to this process. This state we call it somewhere system got hung, where your process is not responding because one process is consuming too much. Okay, so what typically we do, we set that, okay, you cannot use this much of CPU, you cannot use this much of RAM. So you set that. So each container also you can set the CPU and RAM capability. In fact, this feature is available in Windows also. Let me show you. Go to the task manager. Here you have all the processes in Windows running. You see my process. You go to any system and saying that no. This process, I want to set the memory. I want to set the network. I want to set the disk. All things you can set it up. Okay, make sense?
yes. So is there any condition that this throttle occurs like all my containers, they are demanding for high availability of RAM, and or there is some fallback available for this?
No, at the Docker level, there is no as such. Remember, I'll ask you in a simple way. You run Apache in your laptop, you run Apache, Tomcat, this, that. Is there any fallback available in your laptop?
No.
So simple. Container is for running application. You are whatever the expectations you have is for the orchestration. So Docker don't have orchestration capability. Swarm has this one. What is this called? Kubernetes has. Okay.
Okay.
If you liked our Docker session so far, please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devops.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.